You walk through your local park on a quiet morning. You believe you are completely alone with your private thoughts. You assume you are an anonymous observer in the green spaces, but high above you, the quiet trees are watching back. A pair of dark, glassy eyes is locking onto your face. A wild creature is evaluating your movements, your size, and walk. This bird is not just looking for a piece of bread. It is memorizing the exact features of your human countenance. It records the distance between your eyes and shape of nose. They are not just reacting to your presence in the park. They are actively deciding if you are a friend or foe. They watch your hands to see if you carry food. And if you have crossed them, they will remember you. To this bird, you are a distinct character in their story. If you want to understand this mind, look at the trees. They watch our movements and remember our paths through the park. They discuss our behavior with other birds in the high branches. This creates an active network of information above our heads. We are not the only ones who tell stories of others. The birds are telling stories of us in their own language. Here, an intelligence is watching us, judging us, and talking. For centuries, humans believed that birds were simple, automatic creatures. We called them feather-brained and assumed their minds were tiny machines. We thought only mammals possessed the neural hardware for true intelligence. We told ourselves that complex memory required a neocortex like ours. But the birds in our parks are proving science wrong. The crow represents a parallel evolution of deep conscious intelligence. Its mind was built along a completely separate biological pathway. This intelligence is social, cooperative, and capable of holding long grudges. Today, we unlock the generational memory of the wild crow. We reveal the science of how they identify human threats. We show how they pass this information down to their children. Please stay with us until the very end of our journey. We will share an existential realization about our place in nature. We are not anonymous observers looking at the natural world. We are being watched, remembered, and talked about by the birds. To understand this memory, we must look at a university. We must travel to the campus of Washington in Seattle. Here, researcher John Marzluff set out to test crow memory. He wanted to see if wild crows could recognize human faces. Marzluff got the original idea from his own field banding work. He noticed crows scolded him specifically after he trapped them before. But they did not scold other random students walking nearby. This made him realize they recognized him as an individual threat. He wanted to prove this scientifically using unique facial masks. The masks had to cover the entire head and features. This design prevented the crows from using other human cues. The researchers needed to be sure the birds only used faces. They did not want clothes or height to affect the results. So, different students wore the exact same masks during testing. Some students were tall, while others were short and thin. They wore different coats, shoes, and hats during their walks, yet The crows ignored the clothes and focused on the face. They identified the caveman mask immediately in every single test. This proved that crows possess excellent visual identification skills. They pay close attention to the features of the human face. He chose a distorted, ugly mask representing an ancient caveman. This mask had a heavy brow, thick nose, and beard. It had thick, dark synthetic hair glued to the latex cheeks. The latex was colored a dark, mottled brown to resemble age. The expression was frozen in a stern, toothless grimace. He also wore a neutral, friendly mask of a politician. The neutral mask was modeled after former politician Dick Cheney. This neutral face was used as a scientific control design. It had a soft, friendly smile and wore a blue cap. The students walked at a normal pace on the sidewalks. They did not look up at the trees or birds. They kept their arms by their sides while they walked. This ensured that the crows only reacted to the faces. The researchers trapped and banded 7 crows on the campus. During the trapping, the researchers wore the caveman mask exclusively. They ran out from a hidden van onto the green lawn. They captured the crows quickly using hand nets and net guns. They took measurements, weighed the birds, and attached the bands. These bands were orange, green, and blue with black numbers. The entire process took less than 5 minutes per bird. But being trapped is a bird's ultimate nightmare in the wild. They are pinned to the ground and held by human hands. They feel completely helpless and expect to be eaten by predators. The trapped crows were angry and began to scold loudly. They made harsh, piercing scolding calls to warn their neighbors. These rasping sounds traveled far through the campus trees. The crows in the trees watched the entire traumatic event. They saw their neighbors struggle in the hands of the caveman. They recorded the sound of distress and mapped the danger location. This created a lasting association between the face and danger. The birds did not forget this threat. When they were freed, they carried the memory of that face for many years. They warned other flock members whenever the caveman appeared again. This is how a single event created a lasting social grudge. Then, Marzluff decided to walk through the campus again later. He wore the caveman mask but did not trap any birds. He walked naturally, holding books and looking straight ahead. As he walked under the trees, the reaction was immediate. The crows began to scold him and dive-bomb his head. They remembered the caveman face as a dangerous human threat. But when he wore the neutral mask, they ignored him. They went about their daily business of searching for food. This proved the crows recognized the specific features of the mask. They did not react to the human shape or clothing. They targeted the caveman face with clear, directed social anger. But the experiment took a highly unexpected turn over time. As the years passed, the number of scolding birds increased. At the start, only 7 crows had experienced the trapping. But soon, dozens of crows were scolding the caveman mask. Birds that had never been trapped joined the vocal protest. They flew in from neighboring territories to scold the face. They watched the territory owners scream and joined the fight. Even crows that were born after the experiment joined in. They had never seen the caveman trap a single bird. Yet, they scolded the mask as if they remembered it. How did this warning spread through the wild crow population? Crows are highly social animals that communicate with complex signals. They use scolding calls to recruit others to fight threats. This behavior is called mobbing, and it is a shield. By scolding together, they drive predators away from their nests, but they also use mobbing to teach the younger generation. Young crows watch their parents react to the caveman mask. They memorize the face associated with the parent's anger. This is a form of social, horizontal, and vertical transmission. They pass the description of the enemy down to children. This social learning is the foundation of culture in animal societies. The spread of the grudge was not limited to family. Crows from neighboring territories flew in to join the scolding. They observed the local territory owners screaming at the visitor. They trusted this warning and added the face to their enemies. This is a form of horizontal transmission between unrelated adults. It shows that crows learn from their peers in the wild. They do not need to experience the danger to avoid it. They rely on the collective wisdom of the social group. This allows the flock to build a shared map of danger. They keep track of hostile humans across a wide area. If you offend one crow, you offend the entire neighborhood. The warning is broadcast to every bird within hearing distance. This creates a protective shield of eyes and voices around them. The grudge becomes a piece of cultural history for the flock. The caveman mask remained a target for over 16 years. The original trapped crows had long since passed away. Yet, the flock continued to scold the face in Seattle. This generational memory is a powerful survival tool for them. It allows them to avoid danger without experiencing it personally. They learn from the mistakes of their ancestors and neighbors. But how does a bird brain support such complex memory? To understand this, we must look inside their skulls. A crow's brain is tiny compared to a human brain. It is about the size of a human thumb tip, but relative to their body weight, it is very large. It is similar in proportion to a chimpanzee's brain. For decades, scientists believed bird brains were simple and primitive. They saw that birds lacked a neocortex in their brains. In mammals, the neocortex is the seat of high intelligence. It has a complex, layered structure that allows us to plan. Without a neocortex, birds were assumed to be automatic machines. But neurobiologists discovered a different structure in the avian brain. This structure is called the nidopallium caudolaterale, or NCL. The NCL is not organized in sheets like a mammal's cortex. Instead, it is structured in dense clusters of active neurons. These small neurons are packed very tightly in the brain. This high density allows for more connections in less space. It is like having a supercomputer inside a small box. This design is highly optimized for complex processing tasks. The neuron density in the crow brain is truly astonishing. They have more neurons per square inch than most mammals. This high density allows for rapid information processing and storage. The NCL acts as a central hub for these neurons. It connects sensory inputs with memories and future action plans. This integration allows the crow to make decisions in seconds. They can evaluate a complex situation and choose the best path. This is what we call executive function in human biology. It is the same skill we use to solve hard problems. Crows do not rely on simple, hardwired instincts in life. They think, evaluate, and choose their actions based on experience. Their intelligence is flexible, adaptive, and highly responsive to change. The NCL performs the same functions as the mammalian prefrontal cortex. It processes sensory information, forms memories, and plans movements. This is a remarkable example of convergent evolution in nature. Nature built the same cognitive skills using a different blueprint. The NCL is packed with dense, highly connected neuron pathways. These neurons are smaller and closer together than in mammals. This compact design allows the brain to process signals quickly. It maximizes processing power while keeping the head light for flight. The bird's head must remain light to allow for flight. A heavy mammalian brain structure would make flying impossible. So evolution packed the neurons tighter in the avian skull. The crow's brain is a masterpiece of biological efficiency. It shows that intelligence does not require a mammalian layout. A conscious mind can emerge from a completely different structure. This avian brain is capable of remarkable logical reasoning skills. At the University of Tübingen, researchers studied crow consciousness. They trained crows to respond to faint visual light signals. The crows had to report if they saw a light. At the same time, researchers monitored single neurons in the NCL. They found that the neurons matched the crow's subjective perception. The neurons fired when the crow thought it saw light. This proves that crows have subjective, conscious sensory experiences. They do not just react. They possess an internal awareness. This conscious awareness allows them to solve complex physical puzzles. In the wild, New Caledonian crows are famous toolmakers. They live on remote islands in the South Pacific Ocean. These islands have many rich grubs living inside dead logs. The grubs are deep inside holes, out of reach of beaks. Crows develop the ability to make tools to extract them. They search for specific twigs with forks and side branches. They trim the leaves and shape the end into hooks. They use these hooks to pull grubs from tree holes. They also use other materials to build their useful tools. They cut the edges of stiff pandanus leaves with precision. They create saw-like teeth along the edge of the leaf. This tool is perfect for catching insects in narrow crevices. They carry these leaf tools with them as they hunt. They even store them in safe places for future use. This shows they value their tools and plan their retrieval. It is a form of technology passed down through families. Different groups of crows make slightly different styles of tools. This is the definition of cultural variation in animal technology. This is not a simple, hardwired instinct in their genes. They learn the art of tool-making from their parents. They practice and refine their skills over many years. In laboratory tests, a crow named Betty shocked researchers. She was presented with a straight wire and a bucket. The bucket had food at the bottom, out of reach. Betty had never seen metal wire in her life before. She took the wire and wedged it in a crack. Then she pulled the other end to bend it. She created a hook, inserted it, and retrieved food. She had to adjust the angle of the bend carefully. If the hook was too straight, the bucket would slip. If the hook was too curved, it would not fit. She tested the shape and adjusted the wire with her beak. This shows she understood the relationship between shape and function. She solved the problem through active mental trial and error. This planning ability requires a high level of mental flexibility. It is the same flexibility we use to design our technology. Betty proved that birds can innovate when faced with new challenges. This required planning, mechanical understanding, and creative thinking. She did not stumble upon the solution by random chance. She had a mental image of the tool she needed. She shaped the wire to match that internal mental image. This level of planning is comparable to young human children, and this planning is also used to manage their food. Crows store food in secret locations, a behavior called caching. They remember the locations of thousands of hidden food items, but they also monitor who is watching them hide it. If another crow is watching, they will pretend to hide. They stuff the food in the ground, then dig it. They hide the food in a different spot when safe. This behavior is only performed by crows that have stolen food. If a crow has never stolen, it does not worry. It assumes other birds will not steal its food either. But a thief knows how other thieves behave in public. It projects its own past behavior onto the watching competitor. This requires a complex, multi-layered understanding of social dynamics. They are thinking about what the other bird is thinking. They are playing a game of social deception in the dirt. This is a level of social planning that is rare. It shows they possess a rich and complex social consciousness. This requires a cognitive skill called theory of mind. They understand that the observer has its own private thoughts. They predict the competitor's behavior and take preventive action. This social intelligence is also seen in their funeral behaviors. When a crow dies, other crows gather around the body. They scold loudly, calling in neighbors from all directions. This is not a mourning ritual in the human sense. It is a social gathering to assess immediate survival threats. They search the area to see what killed their neighbor. If they see a human holding the dead bird, scold. They associate that human with the death of the crow. They memorize the human's face and add it to enemies. They will avoid that specific location for many days afterward. They know that the area holds a high risk of death. This learning process is extremely fast and highly effective indeed. They do not need to see the predator kill the bird. The presence of the body is enough to trigger the warning. This allows the flock to update their threat map in real time. They share this critical information with every bird in the area. This cooperative learning keeps the entire flock safe from harm. The dead crow becomes a warning sign for the entire flock. This warning is passed to the young who watch safely. Now, let us bring these 3 loops together at last. Let us look at the grand realization of what this means. When you walk through the park, look at the trees. The crow represents a mind watching us from the branches. Its brain is packed with dense neurons in the NCL. Its memory is generational, passing threats down through the years. Its social network is active, discussing us in the leaves. And this brings us to the ultimate, humbling human realization. We believe that we are the sole judges of nature. We look at the world as if we are invisible. We study animals as if they are static objects under glass. But the crow proves that nature is looking back at us. We are being evaluated, classified, and remembered by the wild. If you are kind to them, they will remember you. They will bring you small, shiny treasures as thank you gifts. They will greet you when you walk through their territory. But if you are cruel, they will scold you. And that scold will be heard by their children's children. You are a character in the oral history of the crows. Your actions are recorded in the memories of the flock. This means we are not separate from the natural world. We are active participants in its complex social network. The next time you walk under the trees, remember eyes. Look up at the black shapes resting on the branches. Speak to them with respect and walk with gentle steps. Because they are watching, they are remembering and talking. If this video changed your perspective, leave a like today. Please subscribe to our growing channel named Wild Sentience. It helps us grow and share these stories with you. Tomorrow morning, look out at the beautiful wild world outside. Remember the generational grudges and friendships in the green trees. They are not empty. Unfeeling biological machines in the grass. They are feeling, remembering, and dreaming of their own worlds. I read every single comment on our channel. Hearing your stories is the highlight of my day. It shows how you connect with wild neighbors around you. Tell us your stories in the comments section below today. Thank you for watching, and I will see you next.